All right, guys, in order to complete the questions on your independent practice today, you will need to follow a series of steps. The first being to use your Ruby strategies to figure out what the question is asking you to do. You will then draw and label a picture. If there's already a picture, just label the forces. This will help you stay organized and figure out what you're doing and what you're looking for. You will then use the FMA formula sheet to determine which formula you need to use. So you guys will have access to this sheet, but your sheet will also have examples of how to determine the net force of unbalanced forces. So don't freak out, yours will have that on there. And then step 4, we will plug our numbers into our correct formula and calculate our answer. From there, we'll reread our question with our answer to determine if it makes sense. So the first worked out example we're going to do today is the Eliza 500 is an aircraft coming to a complete stop on the runway, accelerating, keyword, at negative 2.5 meters per second squared. I'm going to go ahead and underline that as well. If Eliza 500's engine is producing a net force, it's giving me my net force, so I'm going to put that in brackets, of negative 1800 N, what is the mass of the aircraft? I am underlining my question. So here is where drawing a picture or drawing labels is really going to come in handy. I was given my acceleration, so I'm going to go ahead and write it down so I can keep track of everything that I have. Negative 2.5 meters per second squared. I was also given my net force, so I'm going to go ahead and write down my force was negative 1800 newtons. So from here, just by my labels, I can determine that I'm missing my mass. And I can go back to the question and see, yep, that's what I need to find. So from here, I pull up my formula chart. I go to mass to determine which formula I need to use. And I see that mass is equal to force divided by acceleration. So I'm going to write that down on my paper so that I don't forget what I'm doing. And it's easy for me to just plug in my numbers. So my mass is equal to my force, which is negative 1800, divided by my acceleration, which was negative 2.5. I am recording on my phone, so I cannot use my calculator to show you guys. But when you put that into your calculator, you get a mass of 720 kilograms. Don't forget your units. So now we found our mass, following our steps, using our formula chart, using our Ruby strategies. Now, a way that we can check to see if we got the correct mass is to plug in our numbers into our original formula for force. So I could say, all right, my force is equal to mass times acceleration. So if I multiply 720 by negative 2.5, I should get negative 1800. And when we put that into our calculator, I wish I could show you guys, we do get negative 1800. But that is a way that you can check to do step 5. All right, let's move on to question number 2. Miss Carter and Mr. Balter jumped for the last piece of cake. Mr. Balter pulls the cake to the right. Oh, I got a direction there. With a force of 1.5 newtons. Miss Carter quickly grabs the opposite side, I'm just going to underline that, of the plate and pulls it to the left with a force of 3 newtons. What is the net force acting on the cake? Which direction will the cake move? Okay, here is where drawing a picture is really going to come in handy. Going back and rereading my question with the information I have underlined. Mr. Balter pulls the cake. Let's go ahead and draw our cake. And it's got a candle on it. Okay, that's our cake. Mr. Balter's pulling the cake to the right. He's pulling the cake to the right with a force of 1.5 newtons. Miss Carter's grabbing it from this side and she's pulling the plate to the left with a force of 3 newtons. So we need to determine the net force acting on the cake, as well as which direction the cake will move. So we need to know if we are adding or subtracting our forces. Are our forces going in the same direction? Nope. So we're not going to add them. Are our forces going in opposite directions? Yes. Mr. Balter's pulling to the right while Miss Carter's pulling to the left. They're going in opposite directions, so that means we subtract. So same directions, we'd add them together. They're going in opposite directions, we're going to subtract them. Op for opposite. So we're going to do 3 newtons minus 1.5 newtons. Don't think we need a calculator for this one. 3 minus 1 gets us 2. 2 minus 0.5 gets us 1.5 newtons. So we've determined the net force acting on the cake, but which direction will the cake move? Well, which direction applied the most force? Mr. Balter with 1.5 newtons or Miss Carter with 3 newtons? Bah, bah, bah. Looks like Miss Carter is going to eat that cake because it is moving to the left with a net force of 1.5 newtons. We did it, y'all.